Hey guys, thanks for checking out my video today. In this one, we are again looking at the M365 Pro, and I'm going to show you how I created a 3D printable battery holder case that holds a 36 volt 12 amp hour lithium battery, which can extend your range basically double. The stock battery is a 12.8 amp, and then adding an additional 12 amp hours gets you to 24 amp hours, which should put you at about 90 kilometers range, which is pretty awesome. And you can see I've gotten some good usage out of it. I even took it out in a fairly, it wasn't raining, but it was drizzling just a little bit, and everything held up really well. Some of the cool features of this are the fact that it has grommets on it. So the 3D print has that built in, so if you buy some extra grommets, the wires can be pushed through there, and it looks really stock. Well, for as much as it can, you know? Pretty decent. So anyways, it doesn't take up very much foot area. You can still tuck your feet underneath it. It really does not cause any usability problems. A lot of people use bags, which is just fine, but I wanted something more rigid to protect the battery a little better, and this doesn't affect folding. It still folds just fine, and it's a really cool project. So if you're interested in seeing how I did it, this is a fairly long video, but it goes through the entire process. So if you don't want to stick around for the whole video, don't, but if you want to see a step-by-step on all the aspects that go into creating something like this, I've outlined the entire process for you. So anyways, thanks for watching. Let's get to the meat of this project. Let's go ahead and take a look at what I've been working on for my M365 Pro scooter. And this is kind of what I've come up with. Now, this pink design right here is another author's on Thingiverse. I will put the link to this in the description, but he made a great battery holder. And I decided that I wanted something that would fit the Littokala 12 amp hour 36 volt battery I got off of AliExpress. And I pulled the dimensions off their page. It hadn't arrived yet when I went to design this, but it actually met specification and it all looked good. So let me just show you how this works. So obviously I needed it to work with this existing 3D part, and I wanted it to not interfere with the folding mechanism, which is normally about right here. And I also wanted a place to stuff the cables and a hole to have a grommet to kind of waterproof things a little bit. So I found this little 3D printable grommet as a reference and used the size to create this hole. And I left a hole here in order so the cables could be stuffed up inside also. So the battery itself will just be in this casing, and then the cables can be tucked up in here, and it also is slightly more aerodynamic. Not that that matters very much on a scooter, but still, you get a nice little design form there, and the only thing missing here is the lid itself, which is right here on the ground, with my little tagline in there. So this was all created in Tinkercad, but that's kind of the concept. So I'm going to go ahead and export this and print it out, and we'll see how it goes. Okay, so just finished printing, and it's black, so it's kind of hard to see, but basically this is meant to hold the battery pack with 5 millimeters around each edge for padding, neoprene or something like that. And this will hold the battery inside. This was printed using a support right here. So this should come right out with a little persuasion. go. And that is the top portion of the case that will house the electrical connectors. And it has this hole on the side that matches the M365 connectors, so I should be able to use a grommet in there that's similar to keep the wires in. So we'll have to get this installed and see how it goes. So this is always a fun part. I have a support in here that was printed just to create a groove so that you can close this up and then screw the top end to hold the battery down, but that just pulls right out and you've got your little groove there. So that's always a fun part of the process. Put that in there and comes right out. Okay, so I'm going to start assembling this. Now this piece will go here, and then this piece will come over the top of it and clamp on like this, and this piece will have the box with its 4 holes mounted to it. And in order to do that, I've got bolts and M4 screws that are 16 millimeter length for the box, and I think these are 12 holding these 2 pieces together. So we'll get that set up and see how it goes. Okay, so that went in pretty nicely. I left this space open. It's kind of hard to see, just so you could reach in and do those screws. In addition, run the wires up there without much trouble, but still hold the battery. It still has a lip on it. And we're just putting the final screws on here to clamp it down. And the case rests up against this rubberized material. Although I may find a way to put a little bit of padding underneath that perhaps, but maybe not. There's room for padding on the inside here, so maybe that's actually the best place for it. So I'll just tighten down these screws and we'll see how it looks. Alright, so got it bolted on there. It is really secure on there. A few imperfections in the print that kind of just came out, but not a big deal. Could probably sand those out. I like the way this looks. Got a nice hole there. Obviously the cover plate isn't in place yet, but overall it really doesn't take up too much of the pad. You can even tuck your toe under it a little bit, so you maybe lose being able to ride with your foot up on the side, which I don't really do very much, but you could do it. So it does take up a little bit of foot room, but all in all, really not bad. I wanted to check out the folding as well to see what happens there. So, oh, you know what? That works just fine. Just keep it straight. That is not an issue at all. Wow, perfect. I was thinking I had to get fancy, but really it just works. Okay, well, problem solved, if there ever was a problem. Okay, so I got the top piece finally printed, and this one just has some 3M screws, or sorry, M3, 3M screws, M3 screws, and there's holes in the edge here that those line up with. And let's just do our first test fit. This is just designed to be able to fit right into those notches. Try to see if I can even do this one-handed, but yeah, it Slides right in, and now you've got a cover, and that fits in pretty nicely. It's a little bit tight. The opening ridge is, I think, 5 millimeter, and this is printed at 4.8 millimeter. Judging by how tight that still is, probably should have done 4.75, because that's a little tight. I guess if you're looking for a good seal, maybe it's fine. 4.8, because you're gonna want it to be fairly tight for, it's probably not watertight, but probably fairly water resistant with how tight that seal is. That's actually not too bad. But it would flow a little easier if you made this a little less thick, but you'd also compromise integrity. This is all done with PETG, so it should hold up to the UV rays of the sun. It's fairly strong and flexible, so it should take a pretty good amount of damage. The battery will be well protected inside that casing. Alright, so I've got my little Y connector here plugged in, and I am fishing using this rod up through the motor housing right here. And you can see that this 3D print that I did, I bought some extra grommets, and as I drop it, and it's actually will fit right over this hole, and it will be able to have the wires go in and still be waterproof. So it should be pretty neat once that's all in. So I've run this rod up and through, and I'm gonna see if I can tape the rod to these two wires and then pull it through. So we'll see how that goes. Okay, I was able to fish these through, super easy. And now what I'm gonna do is run them through that grommet and into this housing and see how that goes. Okay, so now I just need to get the T connector on here. On the back side, you can see that it came through really nicely with this grommet, and I need to drill this grommet out a little bit bigger before I can tighten that back down, but I'll show you once that's tidied up. So I'm just gonna solder this onto here and hopefully be good to go. Okay, now I need to create, a soft padding for that battery. So I have this kind of foam material. I got this off Banggood. I'll maybe put a link in the description. But it's really soft and squishy. Should provide really good bouncy padding. I may do 2 layers if enough fits. I'll put as much in as I can and still close the door. But I'm just cutting out this and then I will place it inside of the chamber on the bottom and on the back and on the sides, and then I will put the battery in. Before I put the battery in, this is at 36.7 volts exactly, and the existing battery is at 36.76 right now, so I am leaving it on and turning on the light in order to drain the battery a little bit to get it down to exactly 36.7 volts with this fluke meter, so when I connect them up we have no issues. So that's the plan, and I'll start putting the padding in here. Okay, so I've got the padding cut and that looks really good and nice and tight. So I'm going to go ahead and peel off the back, and it's kind of like a sticker, and I'll put it on there. And then once this battery drains just a little bit more, I should be able to connect the 2 batteries and close it up and be done. Alright, moment of truth. I just joined these batteries, and so far so good. Scooter's on. I decided that rather than try to tape this padding on, I did on the bottom, but just for ease of, it's pretty tight fit, so just for ease of use of getting the battery in and out, I find it's going to be easier to just use this as kind of like a padding wrap, and then put it in they're like this, and then it's a little bit easier to pull the battery back out because it is a pretty tight fit. So I designed this 3D print. You can see it's got all this room up here to hide the cables. So there's plenty of room, but it's really hard to do while filming. So I'm just gonna try to get that up and in there, all put away, and show the final product, hopefully. All right. So it's looking pretty good. Got grommets on either side. Almost looks stock. And the last thing to do is to fit the cover. And screw it down. And looks pretty decent, if you do say so myself. Okay, so I hope you guys all enjoyed that. It was kind of fun to design something that ended up working really well, especially since I designed it without having all the parts on hand, and I was able to do it in one print. So I will include Thingiverse descriptions to all of these parts, and if you guys want to use my design, it's there for you there. Thank you to all the other Thingiverse people who created the mount and the grommet, and I'll put those in the description. And also, in order to make that battery work, I did a little bit of work on it, changing it from a standard port to a common port BMS on that battery. I'll have a video about how to convert the battery because it's kind of important to keep a BMS intact on a lithium-ion battery. And when you dual hook these batteries up like this, you're kind of bypassing the BMS's ability to manage the cell charge state. So anyways, there'll be further videos on that and a 140 millimeter brake rotor update. This external battery pack has been working out super well. I've taken on several long rides and it makes a huge difference. And it's well worth, if you need the extra range, it's well worth it. So anyways, thanks for watching. More cool videos to come on M365 Pro and other things in general. Thanks for watching.